So we are going to discuss another numerical, and that says that a ship of 150-meter long, okay, arrives at a mouth of a river with draft 5.5 meter forward and 6.3 meter aft. Okay, now so what we have been given is MCTC. Okay, MCTC is 200 tons meter, TPC is 15 tons, center of flotation is 1.5 meter aft of amidship. The ship has then to proceed up the river where the maximum draft permissible is 6.2 meter. Okay, it is decided that seawater ballast will run into the forepeak tank to reduce the draft aft to 6.2 meter. If the center of gravity of the forepeak tank is 60 meter forward of the center of flotation, find the minimum amount of water which must be run in and also find the final draft forward. So as we know, first of all we'll write what all we have been given. So when we speak about what all we have been given, bear with my handwriting. L is 150 meter, draft forward is we denoted by df 5.5 meter. Okay, draft aft is equal to 6.3 meter. Now mctc is 200 tons meter. Okay, tpc tons per centimeter, that is 15 tons. Center of flotation is 1.5 meter aft of amidship. Okay, so this is what is given. So first of all what we are supposed to do is to find the mass of water. So we are supposed to find the mass of water. Now so it is bodily sinkage. Bodily sinkage is equal to m by tpc. Okay, so how much sinkage, that is we are supposed to get it in centimeters. So here we have is 630 plus, sorry, so here we have been given is what is m by 15 centimeter. So this we keep it in separate because there are two variables that is unknown to us. Okay, now when we calculate, now we have to calculate new draft aft. Okay, so that is what, that is old draft plus bodily sinkage. Old draft plus bodily sinkage. Now when we speak about old draft is how much? Thus we take it in 6.3 to 630, we take it in centimeters plus m by 15 centimeter. Okay, now but what is we have been given is 6.3 aft. Okay, from here we have taken, and now what we have been given is 6.2 meter. Now but required draft, but when we have been required draft aft is equal to 6.2 meter, that is equal to 620 centimeter. So reduction in draft aft, so we have how much reduction in draft aft is equal to 630 plus m by 15 minus 620. Okay, this we keep it in bracket. Okay, so reduction in draft, what we did is new draft. What is the new draft? Minus required draft. So this is new draft that we have calculated here. Okay, and this is the required draft that is given is as per the question. So we have change in draft aft is equal to 10 plus m by 15 centimeter. This we make it as equation 1. Okay, now we have to calculate change in trim. When we calculate this change in trim is equal to m into d, this formula we have discussed several times, previous numericals also, mctc. Okay, now few things that we are supposed to remember is center of gravity of four peak tank is 60 meter forward of center of flotation. Okay, so center of gravity of four peak tank is 60 meter forward of center of flotation. Now here, so this change in trim, that is t is equal to m into 60 by 200. Now this 60, that is what is the d. Okay, we denoted in the formula by the d, and this is what distance from center of flotation. Okay, so t is equal to 3m by 10. It is centimeter by the head. Now why this is? Because the water is added to the forward. Okay, now here t is change in. Now what we will do is, now next step is change in draft aft. So we will calculate what is known as change in draft aft is equal to 3m by 10, 150 by 2 minus 1.5. Okay, so now it is to hold to the by 150. Now this is what this formula is, T by L is L by 2 minus X. Now here T is change in trim, T is change in trim, L is length of ship, L is length of ship, and X distance of center of flotation, distance of center of flotation. Okay, so now this is nothing but distance of F from aft. Okay, distance of F from aft. So here it will be, so as per this, now we resolve this 3m by 10 into 1 by 150, 75 minus 1.5. So what we get is change in draft aft is equal to 0.147 meter. Okay, this we make equation 2. Now we have to equate. Now we equating one, equation number 1 here we have calculated, equating 1 and 2. Now when we equate 1 and 2, 10 plus m by 15 is equal to 0.147 meters. Okay, 0.147 m minus m by 15 is equal to 10. Now this L by 2 plus minus x is the distance of center of flotation from forward to aft of midship when calculated change in draft forward or aft. Okay, now this is 10. So therefore 15 into 0.147 m minus m by 15 is equal to 10. So m is equal to, how much we will get, 124.48 T. M is somewhat similar to 124.5 T. So this is 124.5 tons of ballast water must be taken. Okay. Now we will calculate what is known as new bodily sinkage. Now when we go about new bodily sinkage is equal to m by TPC is equal to 124.5 by 15 is equal to 8.3 centimeter is equal to 0.083 meter, and then we have change in trim is equal to 124.5 into 60 by 200 is equal to 37.35 centimeter by the head. Okay, so this is the answer. So new bodily sinkage will be this much and this is this much. Now change in, now we have to calculate the change in draft forward. So change in draft forward, how much will be the change in draft forward is equal to 37.35 by 150. 150 by 2 plus 1.5 is equal to 19.05 centimeter, 0.1905 meter. Okay, now we have what is known as change in draft aft is equal to 37.35 by 150. 150 by 2 minus 1.5 is equal to